Bismillah. So last time we continued talking about how to describe the random variable, and we defined two functions here. The probability commutative, so the commutative distribution function, which we called the CDF. Okay? The CDF. The commutative distribution function, and we call it commutative because we actually add the x increases, we keep accumulating the probability until it reaches 1. And we talked about the properties of this. And then we said, okay, that was a commutative distribution function. What about if we differentiate that commutative distribution function? This should give us how is the probability distributed among different values of x. And this led us to the definition of what we call the probability density function, PDF. And we define it as small, we gave it the notation as a small f rather than the CDF, which is a large f, capital F. And the subscript here is donating the random variable. So this is the probability density function, the PDF of the random variable x, as a function of x, which is a number in the real. And we went through some examples and we said, okay, this tells you how is this one, total one, this is among the different values of x. And if we differentiate a typical, for example, discrete CDF that we have seen here, we will get basically a series of impulses. And every impulse will have a location at the value that the values that x take, with the amplitude of the impulse will be equal to that x equals that value, x1, x2, x. Okay. Now this should give you some visualization about how is this total probability distributed among the different values. Okay, and then we went through some examples, and we gave the example of LEC8 and the continuous. This is basically was the continuous part. So you can see that here the PDF shows that it's equally likely that the random variable takes any value between A and B. It's equally likely because it's a state. Now, if you integrate this, it means that as x increases between A and B, the probability keeps accumulating in linear fashion. So basically, it's and then we talked about the properties, and we said that in order to be able to figure out whether any function is a valid PDF or not, it has to be positive. It has to integrate the area and the detail to be equal to the total probability of 1, because this is a density function. And since the PDF is the derivative of PDF, then the CDF is the integral. Okay? And if we are interested in finding the probability that x lies between two numbers, then we just integrate the PDF between these two. Okay, and we say that, okay, in order to verify, it has to be positive, integrates to 1, and basically these two things. Now today we'll continue with more examples, and then we'll start with the Gaussian distribution. Gaussian is a very well-known distribution. It's a very well-known distribution that is very interesting to understand and very important to understand and master. Now in this example, this is an example of the sample space. It's a filament with a sample space given by this. I can see. Now, please, I want to say that I will not allow late comers. However, please make sure that you come with them. People stick. I assume إنه ما أتصلكم close by. واحد اثنين بس. يعني هذا لازم يكلمني. Otherwise, I assume that you are around. So basically, in this example, the sample space is basically any number between -4 and 12. It's a sample space. It's an experiment. We don't know even what it is. And the random variable is defined as a function of the sample space I, sample space element I. So xi here is -2 when I is less than -2. And xi is equal to I when I is between -2 and 1. And the random variable is equal to 1 for I between 1 and 4. And the random variable is equal to 6 for I larger than 1. So now the question here is show the mapping of the random variable from the sample space to the random variable and what type of random variable. What are the findings? Is it discrete, continuous, or mixed? Continuous, we do continuously. من 2 ل 4 من 2 ل 4 من 1 ل 4 this is constant, so this part is discrete. We do continuously. Can X take uncountable value? A value out of uncountable value? Follows. It's equal to which makes it continuous, right? However, when it is 1 or 6 or minus 2, it's 3, right? So let's now if we would like to see the mapping between I, which is the sample space element, I here belongs to S, which is a sample space element, and X. Then basically for I less than minus 2, the value of the random variable equal to minus 2, as you can see. It's minus 2. And for I between minus 2 and 1, according to the definition, it's equal to 1. It's a linear curve. And for I between 1 and 4, in the third line here, it's equal to 1. And in the last thing, above 4, 4 to 12, it's equal to 6, as you can see. And clearly it's a mixed random number. Because it takes some discrete values, as you can see here, 6, 1, minus 2, and it has some continuous part, which is, I said, the subset of uncompleteness. Fine. Any question? Yes, sir. The density? Yeah, I did not tell you in this particular example, how is this sample space? What is the probability function of this sample space? لما أعطيك sample space تعطيني إيش probability function صح؟ يعني مثلا using a point, there are 8 elements. مو كل 8 elements. The 8 elements are equal probability. That in numbers that come, your 2 heads or 3 heads or whatever, they don't have equal probability. نفس الشيء on the line, and counting or adding the 2 numbers. 526 heads, right? However, when you look at the 2 numbers only, not all of them have the same probability. So I did not tell you here what is the probability distribution. However, assuming that it's uniform, assuming it's equally likely to be between minus 4 and 4, assuming that, then how can we write the density? What will be the density? What is the probability in order to find the density function, assuming? Okay. I is equivalent between minus 4 and 12, right? What is the probability if we want to ask what is the probability that x equals can take equal minus 2, right? What is the probability that x equals minus 2? Yes, well. The random variable takes values from minus 4 to 12, right? Sorry, the sample space from minus 4 to 12, equally likely. So when does the random variable equal minus 2? In minus 4 is a minus 2. What is the width of this? Divided by what is the total width? Total width, it's 12 plus 4, right? 16. So x equal to is equal to its equivalent or equal to the probability that I is less than minus 2. صح ولا لا? This is the event on the random variable on x, defined on x, وهذا الevent defined on where يا شباب? On s. So in order to find the event defined on a, the probability of any event on x, you need to go back to the definition of the sample space. This time or equal. Yeah, thank you. So what is this equal to? Because of equal probable, هذه الكلمة، هذا هو السر. This is equal to the width of 2. Basically, let's see. It's minus 2 minus, minus 4, which is the width, divided by 12 minus cam, minus 4, which is equal to 2 divided by cam, 16, which is 1 over. So the probability that x equals minus 2 is 16. Right, let's continue. What is the probability that x equal ايش بعد؟ x can take what values يا شباب؟ ايش النكست value؟ I. لا x ما cannot take I. X can take a continuous value between any value between minus 2 to 1, right? So x between x is between well equation 2 minus 2, right? 1. What is the probability of this to happen? It's the width of this, which is kam 3 divided by 16, right? So this is the probability that x can take any value between minus 2. What is the probability that x takes a specific value equals 0? 0, yes? Then it's 1 over and counts it. Right, what else? What is the probability that x equals kam? That's the next value. 1. This is equal to the probability that x is, sorry, I between 1 and 1, which is again equal to 3 over 6. So this is equal to the probability that I minus 2 I إلى 1. This is the same as this. طيب آخر probability كم يا شباب؟ x equal كم؟ 6, right? It's equal to the probability that I is larger than 4, which is equal to كم? 8 divided by 6. So now if you look at the PDF of x, the PDF will have one impulse at minus 2, right? So basically, if we look at the PDF of x, f x or x, and this is x. X can take values from minus 2 to 1, and what else? Minus 2, 1 to 6, right? And in between 1 and minus 2, okay, so basically at minus 2, it's finger, right? How many finger have equal to? 1 over 8, right? And the probability of minus x equal minus 2. What is the probability of x? Can I show discrete? X equal 1. Come the probability? 3 over 16. Right. What about x6? Right. And in between, what is the probability? Between minus 1 and minus 2 and 1. What is the PDF? What does the PDF look like? It's the total is 3 over 16. Total. Probability that x is between here and here is 3 over 16. However, 3 over 16 divided على 3, right? على width of 3. So basically, this will be a number. It's like a uniform with an amplitude equal 3 على 16 divided by length, which is 3. هو 1 minus 2, which is 3 over 16 over another, which is 1 over 16. Okay. Now, if you sum all these, 1 over 8 plus 3 over 16 plus half plus the integral here, if you integrate, اللي هو يعطيك 3 over 16 المفروض يعطيك كم؟ 1. Okay. واضح شباب؟ يعني تجمعوها الآن. This is half, which is 8 over 16. And this is yeah, 2 over 16. So we have 10 over 16. And we have 3 over 16 plus 3 over 16. The summation is clearly equal to 5. all x values equal to EI. Now you can integrate this and you get your series. Now,
why did we divide by 1 minus
لأن احنا نعرف إنه the probability that x is in this region is equal to 3/16. And then we said that the I is equal probable. So basically it's equally probable that x is between -1 and -2 and 1. Equal probable means it's a unit, x a unit. Equal probable. Okay? And we divide it by 1 by the width because this is the probability of everything. Of being between -1 and -2 and 1. However, what is the probability? Basically, so the area under the curve should be 3/16. And hence the probability the amplitude of the PDF should be divided. Okay? Clear? Mapping هذا بس to show you how to map from I S to X belonging to X. Okay. It's similar to this. أي سؤال ثاني. They are very important to understand how to go from the sample space to the random variable space and how to find the corresponding PDF. Now another example. We have a sample space here of an experiment. S is given to be 0, 1, 2.5, and 6. Equal probable. So it's given that the random variable is equal probable. The random variable here is equal to 2s. So this is the definition of the random variable. So what is xs? So the sx, which is the range. The range of s. What is the range of s? This is s. What is the range of s? Range of x. Well, values that x take. X is equal to 2s. So what is the range of x? 0, 2, which is 1 multiplied by 2, and 5, and 2.5. And 12. Thank you. So basically, we can have 0, 2, 5, and 2. And because they are equal probable, كل واحد منهم عنده probability of 1. Now another, so this is the PDF. If we integrate this, we get the CDF, which is basically a step. أي سؤال؟ Third example. Now this is about checking whether this is a valid PDF or not. We give you this PDF that looks like this. It's an exponential, two-way exponential, which is basically with an amplitude of e to it's a exponential of e to minus x minus m. So it's centered around m, and because of the absolute, it decays symmetrically from the value, which is camel value here, a, until it dies off at 0. Okay, this is a symmetric exponential. وهذا مهم جدا هنتكلم عنه بعدين لما ناخذ Laplace. Now the question is check whether this is a valid PDF. This is called Laplacian density, Laplacian variable. However, check whether it's a valid. In order to check whether it's a valid PDF or not, what do we need to check as well? No condition. It integrates to 1, and it's positive. أول شيء, is it positive or not? Positive. E to minus whatever, E has to be, يعني if A is positive, المفروض إنه أعطيك إنه A positive. This is A. A and B are positive. So A is positive. So if A is positive, then this is an exponential. Exponential is always positive. So this is the first thing. So the first thing is it's positive. Check. Now the second, whether it integrates to 1 or not. In order to find this, you need to integrate this under the area under the curve. You need to find the area under the curve. So simply you need to integrate from minus infinity to infinity of the PDF. It's a simple thing. So this is symmetric. You can integrate from minus infinity to infinity, but because it's symmetric, you can integrate one way and multiply by 2. And this is what we did. We integrate from n to infinity and multiply by 2. of this. Now integrating an exponential gives you an exponential, and it gives you basically a value of 2ab. Single values. Now 2ab needs to be equal to count 1. So in order for this to be valid, this has to be equal to 1 for fx of x to be valid. Okay. So basically, in order for this to happen, then basically the relationship between A and B has to be A equal now. Sorry, 1 over 2B. Okay.
What does B represent?
B represent is basically the width, controlling the width. If B is large, then basically this decays slowly. If B is small, then this decays sharply. So B basically gives you the width. طبعا you can see that A and B has to be related. Otherwise, B controls the width. So if B is small, it will be narrow, right? If B is large, it will be wide. معناها الاريا under the curve is A. بس تتغير صح ولا لا؟ The area under the curve should be tied with A. If the curve is wide, the amplitude has to be small. If the curve is narrow, the amplitude will be large. And because of that, A and B are related inversely, as you can see. A equals 1 over 2. If B is large, معناها ايش؟ It's a thin, narrow curve, which means A will be large. Otherwise, and vice versa. أي سؤال كمان؟ طيب, another question. Now today is the day of examples. Okay, so now we have a PDF that looks like this. It's a triangular function from -1 to 1. أول شيء, is it a valid PDF? Right? Clearly, there are no negative parts. ثاني شيء, how do you know that it's a valid PDF? Second condition. It has to integrate to 1. ايش معناها؟ كم A has to be equal to? A has to be equal to 1, right? Otherwise, this will integrate to larger than. Other function. So basically, A has to be equal to 1, basically, from the area equals. Okay. Fine. Now, the second thing, we'd like to find the CDF. Finding a CDF. How to find the CDF? You need to do what for this? Integrate. So in order to integrate, you need to write the analytical expression for the PDF. How does the PDF look like analytically? Fx of x equal what? We need to write it as 2 parts, right? One part for x, and it's 0 before -1, it's 0 above 1, and it's something between -1 and 0, and another thing between 0 and 1. What is the thing that is between -1 and 1 and 0? Nice one. Now, A, not T, X. X is plus or minus? 0. Plus 1, no? It's the X, which is also 0, plus 1, basically it takes it here, and it's only valid for X between -1 and 0. And what about the other part? It's minus, huh? A of x minus. Okay, it's x minus 1 over opposite. It's the slope is, isn't it? And this belongs to x 0 to 1, and it's 0. Okay, so now if we know this PDF, then we can integrate, right? Now integrating this, what will give you? So the f(x) of x will be the integral minus infinity to x of f(x) of x. I will not do the details, right? Now for every value of x, so basically until -1, before -1, what is the value of x? 0, because it's integral of 0. And between -1 and a, what would be the value of fx? It's the integral of this. It will be like square factor. Okay, it will be ax squared divided by 2 plus x, ax. Now, in this region, what will be fx? The integration of this, right, will be basically like the opposite of the square. It's something that is going down. However, it basically adds to whatever this is. And similarly, what is the integration here? Not 0. Basically, it has to be 1 because it adds to the risk. So now, if you look at it, it will look like this is -1. This is 1. It will look like something like this 0, and then increases, and then starts to decay, and then crosses 1. The integration, the details you can find in one of the examples. Okay? Clear? How do we find this? Now, find the value of fx at 0. What is the value of fx at 0? Yeah? 1. First of all, in order to find this, you need to go through this complicated integration and find it. Do you need or not? Do you need or not to find fx of 0? Do you need to find fx of x? PDF. No. One way is to look at this and just plug 0, right? Find the value at 0. Come the value at 0, you'll find its half. This is one way. However, this is if you find this. Suppose you are not with this one. I did not even ask you to find the analytical solution. As you can see, it's not an easy case. Suppose I did not ask you, and I asked you for this. How can you find it? The PDF, right? Integration, exactly. So basically, without looking at the CDF, this is equal to the integral of the PDF. From where to where, Shabab? -infinity to 0. And that's it. Without going through the hassle of finding a complicated CDF, I need just to integrate the PDF from CDF. And if I do that, what do I get? Integration of this. It gives me half of that. Half triangle. Basically, it gives me one triangle out of 2, which is it was symmetric. If it is symmetric, the PS is always. So this probability will be everything. So basically, the question of your friend, if the PDF is symmetric, regardless of the shape, is symmetric around 0, then what is fx of 0? It will be always 1. If it is for symmetric piece. What did we say here? This is equal to what? Probability that x is this like or equal 0, right? So just to complete. Right, question. Isymmetric around 0. The probability that x is less than 0. Basically, it's symmetric. Now, determine the numerical value of b such that probability that x is larger than b equals half fxb. How can we do this? So I'm giving you, I'm asking you about a number b that will ensure that the probability that x exceeding b equals half. What is this? What is fx of b? PDF, what is it equal to? Exactly. Thank you. This is the probability that x is less than or equal to. So اللي جالسين نقول احنا نبغى b such that the probability that x larger than b is equal to half the probability that x less than b. Okay? It's a funny question. Can we do this? Yeah. What is the probability that x is larger than b? It's the integral from b to infinity of fx of x. Okay, dx. And this needs to be equal to what? The probability that minus infinity to be of fx x dx. So in order to find this, you need to find this, and you need to find this, which is 1 minus, right? Okay. This will be 1 minus the integral from the infinity, right? fx x dx. We're going to have, will be half. So I can be equal to half of that. Is half. Okay? So it will be half minus half of this. So you can see that you need to integrate this, you need to integrate this, and the equation, and you get what he is. Any question? So basically, now solving this, we give you what? We have b, this is integral, this is integral. We take this here, it will be 3 over 2, integral from b, infinity, fx, x dx, right? This is equal to 12. Half. We have half. So this means that 3, basically this integral has to be equal to 1/3. Now we need to find what the integral is and this. أي سؤال؟ Clear? Questions? So you can see that most of these questions, the first step is the probability part, the rest is what? So basically, the probability, the P15 part of most of the questions that you will see will be the first, probably the first step, or the maximum the second step. The rest are no. So in our course, we try to not to examine you in math. So basically, we try to usually give simple integrals and so on, not to examine you. Fine. So basically, by this we are done with the PDF, CDF, the properties, some examples. What do they tell about the random variable? How are they related, and so on. So what is the rest of the class and coming to probably 2 classes will be devoted for some. Sorry, the rest of this class and the next class will be about Gaussian distribution. And after that, we'll study some well-known distributions, binomial, uniform, Poisson, and that. Okay. So now today the focus will be Gaussian. What does Gaussian distribution look like? So in Gaussian distribution, let's be mapping from sample space to a Gaussian, what we call Gaussian distribution. What does Gaussian distribution look like? The density, the Gaussian density, first of all, is very important. Basically, is the most important density that you will encounter in any problem because of many reasons. One of the most important reasons is that 2 reasons. First of all, it describes many physical phenomena. Like, for example, taking an example, for example, let's see, for a large sample of students, most likely the distribution of the exposure will be Gaussian. And not 101, 102, 001, exactly. In a large volume of students, usually we find that the distribution of students will be Gaussian, focused around the mean. And as they go out away from the mean, the volume becomes smaller. So the first reason is that it describes many physical phenomena. The second, it basically uses what we call the central limit theorem. If you add many random variables together, there is a theorem that we will not discuss in this class. However, it's called the central limit theorem. It says that if I have many random variables, regardless of the distribution, and I add them together, then the resulting distribution will look like a Gaussian distribution. So if I have, for example, if I'm looking at the noise in circuits, the noise can or get generated from different components of the circuits, different resistor, diode, and so on and so forth. amplifier, antenna, and so on. All these added together will give you at the end one noise. This noise will be Gaussian because it is the sum of many independent fundamental. Okay, so because of these two reasons, the Gaussian random variable is extremely important. And because of that, we are focusing on it in one full section. In general, you will read in this book or different books that either you call it Gaussian because the person who invented or who discovered this distribution is scientist Gauss, and because of that, it's called Gaussian in this particular, or we call it normal distribution. Normal because it describes the normal behavior. The normal behavior of things. Okay? زي ما قلنا noise, exams, and many other things. Basically, so this is the normal behavior of the nature that ends up with a Gaussian distribution. Now, if you are already integrated, why Gaussian is important? Because, as I mentioned, it describes many factorial phenomena, and because it is the sum, or basically it models the sum of many random variables. And because it's called normal, then let's talk about the details. Okay, I saw about this. Why is it important and where we will see it? Basically, you will see it in many applications. Let's see our once we understand why is it important, let's see what is it? How does it look like? First of all, a Gaussian random variable خلينا نتكلم على أول شيء كيف شكل الPDF. The PDF looks like this. It's a bell shape نسميها. Bell shape شكلها كده مثل الجرس. Then this is a bell shape PDF. هذا أول شيء. Bell shape. PDF. Okay. It is centered around the mean. It is centered around اللي نسميه ايش؟ الافرج. المعدل. The average. Okay. And the peak of it has this value. Okay. The maximum occurs at the average, which is the average هنا equal كام يا شباب؟ AX in this particular variable. لا تحسب معي. This is the first thing. So it's centered around AX, and because of that, it looks like an exponential e to the power x minus what? E. So it's centered around. So the first variable, the first thing that you see in the PDF is the average, the mean. This is it, the first one. Now the second one is what we call the variance. Sigma x squared. Sigma x squared is the variance. What does the variance mean? هسه أحد يعرف الفاريانس؟ ها؟ تغير، يعني بداية التغير. لكن الفاريانس أنت تعرف شيء أصعب من الفاريانس. الإجمال اللي هو إيه؟ لا إيش يصير؟ يعني قبل إيش بعد؟ لا هذا الكلام. كيف هو الإنتجريشن؟ standard deviation. Standard deviation is something important to you. Why? ليش لا تكون standard deviation؟ ليش لا نتكلم في orientation في الماث؟ Physics أعطيكم either median the average and standard deviation. Why is standard deviation? It tells you how spread a distribution around the average. يعني مثلا إذا standard deviation is very high تلاقي ال PDF عريضة. So this has a large sigma x. This one. لو تلاحظوا شو كيف. So basically around the mean, around the average 0, students take values very far from zero, like very far from the average and very far from the average in the analysis. الشباب معظم موزعين كمية النتائج الاختبار متوزع مرة بشكل عريض around the mean. بينما هنا this one has what? Small variance, right? Small sigma x. Why? As you can see, it's focused around the mean. تلاقي مثلا average 50 أو 60 تلاقي معظم الشباب within إذا 60 تلاقي معظم الشباب من 50 إلى 70. بينما هنا إذا الأفريج 60 تلاقي الشباب منتشرين من 100 إلى 7 ولا 5 ولا 10. أوكي؟ this has a small variance, this has a large variance. الآن what is فإحنا آخر شيء we need the curve to be the area under the curve equal 1. So if you have a large variance, the amplitude here will be small. So the amplitude here is inversely proportional to the variance. Right, so I go to standard deviation. Huh? How is standard deviation? Sigma x is a standard deviation. This is the variance. Sigma x. Sigma x is called standard deviation. Okay. Now, if you look at 1 sigma x, so basically 1 sigma x from the mean, okay, then the amplitude will drop to 0.607. Similarly, 1 sigma x minus 10. And you will see that the area under this curve will be the same, 2/3 of the whole population. So if you look at the scores of students around the mean within 1 standard deviation, أحد يكون standard deviation واحد، لكن كثير كلها مركزين في هذا الarea. Okay? Okay? So now you can see that if you have a large variance, this amplitude will go down, right? Large variance, and the area should be equal to 1. So if you have a large variance, then this will be smaller amplitude. And when you have a small variance, then the amplitude becomes, as you can see. So the PDF looks like this. It's 1 over square root of 2 pi sigma x squared, which is the variance, e to the minus between 2 parentheses x minus the average all squared divided by 2 twice h variance. Okay. It looks like this. Why it looks like this? Because this function describes this bell shape. Now, what is this constant? Why is it needed? No? Why is this constant needed, Shibab? To have the area under the curve equal what? 1. The PDF has to have area under the curve equal 1. Okay. Now, what is the value of the PDF at x equal ax, the average? If I put ax equal ax, what do I get in this exponential? Exponent 0, so the exponential will be 1. So what is the amplitude? Sorry, what is the value of the PDF at x equal ax? It is this, which is the maximum, right? It is this value. 1 over 2 pi sigma x squared underscore. Now at x, a minus sigma x, a plus sigma x, as we mentioned, it is 0.607 divided by the same amount. Okay. Now the notation that we will use looks like this. X is distributed, هذه معناها distributed according to. So this means distributed according to. This n means what? Normal. Huh? Normal distribution. With what is mu here? Mu here is the mean, our average. What is sigma squared? Variance. So this is the notation that we will use in many classes to come. When I tell you that x is like this, means distributed according to. N means normal, so it's Gaussian. With the first number being the average or the mean, the second number being the variance. If I give you this, you give me this. If I give you this, you will be able to solve anything. Basically, you don't need more than the average and the variance to basically to tell anything about the Gaussian distribution. Okay. Now, looking at, well, this is very important, as we mentioned. looking at the curve as you mentioned. So this here we have different curves. We have the PDF, different PDFs as you can see. A PDF with large variance, with small variance, and variance in between, lower red. And all of them, the three of them are around, what is the average? Now, if we change the average, here, this is a Gaussian distribution with an average equal to -2. So you can see that when the average is different, the location of this bell shape will be changed. Instead of around 0 within, in this examples, it will be around -2. In general, it will be around x. So the average, the value of the average, the value of the mean will decide where this is located in the x-axis. Is it around 1? Is it around 2? Is it around 1? Now, if you integrate the PDF, what do you get? CDF, right? CDF. Now, this is the same. This is the CDF of the corresponding PDF that you can see. For example, you can see that for when you have a large variance is this one. Large variance, large segments. Okay, you can see that the probability that x is, for example, less than -4 still is not 0. It's a good number. The probability that x is less than -2 is a good number. It's probably more than 0.2. But anyway, if I go to the small variance, which is this one, what is the probability that x is less than -2? Almost 0. Why? Because most of the population, most of the probability, most of this probability total equal 1 is focused around the mean. بينما هنا, no, it's very wide display. The last point is when the mean is different, then the CDF will be located in a different place. Here, تشوفون كلهم they cross at 0.5. بينما هنا the whole location is different because the mean is different. Next time, inshallah, we'll continue more. اللي ما أخذ الكويز يجي ياخذ المدرس ويجي I think. ما أخذ الكويز. سؤال فقير. معاذ صالح. سيد فضل. فارس الحربي. معاذ القحطاني. محمد العوض. أنس محمد. ريان الحبيب. ناصر. التحقيق الرحمن عليكي. عبد الصادق. معاذ القحطاني. الرحمن عليكي. My good solution is why not? Thank you. ذكرونا دائما يقفل لأنه يصير ملف كبير.